Hi, I'm Josh McGrath, Soil Management Extension Specialist at the University of Kentucky in Lexington. In this presentation, I'm going to talk about more advanced soil sampling for precision ag. So we're going to talk specifically in this presentation about grid sampling. When we talk about soil sampling for traditional agriculture, you're just trying to represent the average for the whole field because you're going to put a flat rate across that whole field. But precision ag attempts to break that field down into smaller components, zones, and tries to vary the fertilizer rate to match need in a very spatially explicit way. There are two strategies for soil sampling for precision ag. The first and the most common is grid sampling. And grid sampling can be either grid point or grid cell based. And I'm going to talk about grid point for the rest of this presentation because I think that's the most common. The other strategy that we'll cover in a separate presentation is zone management or directed sampling. And these figures kind of show examples of each. At the bottom there, we see that the grid sampling, you put a point at the intersection of different grids and you go out and sample each one of those points, typically 2.5 acre grids. So the intersection of squares that are 2.5 acres in size. Some people try and go finer and go to 1 acre. With zone management, you're just breaking that field down based on input data and you try and separate out areas that are more alike for management. So grid sampling is best when previous management has altered the nutrient status within the field. Some examples of this are combining smaller fields into large fields. Maybe there's that old tobacco patch in the middle of a cornfield and it has a lot higher phosphorus than the rest of the field, and sometimes you can find that. Or there was an old farm with livestock or a livestock pasture or heavy use area, and so it's going to have a lot higher nutrient status from that manure deposition than the rest of the field, and you've combined those together. Also, it can help to pick up on striping from things like overlap and fertilizer application. Grid sampling, is going to pick up on those man-made differences, whereas zone sampling is going to pick up on more natural variation. So when you grid sample, the key to it, to making those pretty maps we get back from our consultants or soil test labs, is the interpolation. So with grid point sampling, you go to that intersection of those grids. So let's say that these are 1 acre grids. And each one of these numbers represents the soil test value at the intersection of those 1 acre grids. And so you can see that you get a bunch of different numbers at each one of those points. But that question mark in the center, that's an unknown point. We didn't sample it. It falls in between 4 sample points. And so now we're going to do a statistical procedure called interpolation to estimate the value at that unknown point. There are different methods of interpolation. This presentation is an overview, so we're not going to get detailed about that. But just know it's a statistical procedure where the nearest neighbors are more heavily weighted in predicting that unknown value. So in this case, those 4 closest circles are going to be used, kind of an average of those, are going to have the biggest impact on what that prediction is at that unknown point. So interpolation causes problems with grid sampling. And actually, I know that a lot of us have been doing grid sampling for many years and have a lot of data and spent a lot of money on grid sampling. But I think many people are surprised to find out that that may have been wasted money. It's not that grid sampling isn't beneficial. You can learn a lot about variability across the field from grid sampling. But the interpolated map is often wrong because those samples have to be collected close enough that they're correlated. And there's this paper by Lauzon et al. From 2005 that's a really good paper. There's the reference for it. I really recommend you looking it up. Or you can send me an email and I can send you a PDF of the paper. It's a pretty easy read and it explains this. And we've duplicated this work here in Kentucky. So what this figure shows is that, first of all, an R value or correlation factor of 0.3 is required for interpolation to have any value. If your R value is less than 0.3, then the predicted value at that point where you didn't collect a sample, the prediction is probably wrong. And so what Lauzon showed is that you need to be around 20 to 30 meters before you hit that R value of 0.3. And so that 20 to 30 meters, so around 60 to 100 feet, separation distance between sample points. That is 1/4 acre to 1/10 of an acre. Now, obviously, I'm not going to advocate for taking a grid sample on 1/4 acre or even 1/10 acre. That would be time and cost prohibitive. We've gone out and done that for you. We've gone out and we're taking grid samples from a number of fields in Kentucky on 20-meter increments, separation, 20 meter between points, so about 1/10 acre, 10 samples per acre. And what we're finding is that that 1 acre or 2.5 acre grid is inadequate for our soils, and the prediction is way off. And you go, well, it's still probably better than just doing an average for the whole field. In fact, that's not true. So what our research has found is that the field average is often better than that interpolated 2.5 acre grid map. So at this unknown point that I highlighted here with the question mark, the predicted value by an interpolation will be heavily skewed by that one high value next to it. Whereas if I take the whole field average, it's going to be closer to what that value. I go back to that point, I actually sample it, it's going to be closer to the field average than the interpolation. And this is just math. It's not a matter of kind of personal preference or opinion, but it's the way the math is done for interpolation. And soil properties are stochastic. What that means is in small distances, you get a lot of random variation, but they follow a trend. So that points that are closer together, they do tend to be more alike than ones that are further apart. But for that interpolation to have value, your points have to be pretty close, because in a 2.5 acre grid, those sample points are so far apart, they have no relationship to each other. So making a prediction based on those 2 or 4 points is way off the mark. So your fertilizer rate at this point, if you have 1 acre grid data, should be based on averages of that grid data. Now, maybe you can break up some zones, and we'll talk about that, but you shouldn't be trusting that interpolated map.